me go ahead and put this into the question box in case you guys don't already know the URL, but it should be pretty easy to figure out. And I think I'm going to go ahead and let's see here. Maybe I can clear this all out. As we did CodeCombat last year for JavaScript, and got through, I think, like 2 or 3 worlds, and now everything automatically populates with JavaScript. And one of the unfortunate things about CodeCombat is it I don't want to delete the account. It keeps the code in from the last time you worked on it, even if you change the programming language, and then everything just turns red and freaks out. So let's see here. Well, never mind then. Okay, so yeah, you're going to have to create an account and enter into the world. And you should have, once you've created that account, you should have a few different worlds available to you. Obviously, they're an increasing difficulty the more you go to the right. So it looks like the Kelvin Taft Glacier and then the last one are new from the last time I used this. Anyway, if you hit play on the leftmost world, Kithgard Dungeon, it'll ask you to set up a hero. And you can choose, a few different types. I choose Sir Theron just because, I don't know, big giant shield and stuff. But you could be either one, really. And make sure, of course, in the drop-down menu here, under the hero select, that it is set to be Python. That is the default, but, sometimes weird things can happen. Yeah, I'll give everybody a minute or so while to set up accounts and stuff like that before I move on. Apologies, I'm also spraying water at the cat because he's clawing at things he really shouldn't. Anyway, okay, so now let's go ahead and hit save now that we've got our hero selected. And the first one, the name is not popping up. It's just called Dungeons and Kithgard. Okay, should be the only selectable one, and then you should be able to outfit your. See, this is the thing. Okay. Python, next. There we go, perfect. And you should be able to outfit your hero. Basically, the difference in equipment, some things may give him more hit points, which are good for attacking monsters and stuff like that. Some give him additional functionality. That is to say, like this one, the sword gives him the attack skill and the cleave skill, which, you'll worry about later. The shield gives him the ability to block things. The tome up here gives him control structures and things like that. The glasses give him the ability to recognize other enemies. And these are all programming functions. that you'll get more familiar with as we get further into the levels. So with that in mind, yours probably should look different from mine, I think. It's probably going to be a simpler outfit, but that's okay. You know, whatever. Anyway, just go ahead and click play. And again, it's going to pop up with, yours is not going to pop up with so many errors because, and also it's probably going to load completely. Mine is automatically populating with the JavaScript code. So the comments look different, and it also has different functions, sort of. So with that in mind, once I correct this first program, we'll take a really quick look at it. Alright, so you remember, if you were here on Wednesday, maybe you remember how I was talking about how Python is an object-oriented language, or at least it acts like one. And we use the example of cars. Cars being an example of an object, where they have like qualities to them, like what color they are, or their make or their model, what type of engine they have in them, the size of the gas tank, stuff like that. And then they have things they can do, like they can drive, they can turn, you know, you can honk the horn, you can turn the car on, things like that. And if you'll remember, the qualities of the car were an analogy for variables in programming. Basically, blocks of memory that allow you to hold information in them, and you can change that information throughout the course of the program. So you can have like a variable called hero health, for instance. This guy's health. And it might be stored with an initial number, in this case 225 on mine, and that can change throughout the course of the program. He can lose health by being attacked. He can gain health back by picking up health power-ups. We can change the maximum amount of health by equipping him with better armor and stuff like that. So instead of starting at 225, it could start at like 300 or something like that. And conversely, it could go down to 100 hit points after he gets into a couple of fights. Stuff like that. The thing that governs that value, holds it, keeps track of it, and that you change is the variable. And the name also makes sense too. It's a variable. It changes. It varies. Anyway, the things that a car could do were an analogy for functions. Functions being blocks of code that are instructions, and they don't literally have to be like entire paragraphs of code or something like that. You could have a function that's just one command, and you know, you could call it, and the computer will just run that one command every time. But functions can also be, if they really needed to be, pages and pages and pages of code that are repeatable. So like, whereas hoghorn could just be like one line of code, convert fuel into forward momentum could be several, at least lines of code, could be paragraphs depending on how far you abstract it. In addition, you can also, we'll get into that later. But anyway, what we want to know is how can we tell what we're looking at? What's what? Which is which? How to write what we need to write, things like that. Well, one of the biggest indicators is the access modifier. So let's say we have this statement, right? Now, just by looking at it, you can probably make an educated guess that what we're saying is an object, a class, or an instance of an object, rather, called car, is being told to honk its horn. So this is the what we want it to do, and this is the where we find the call for the command. Actually, let's change that. It's better to say it's who. Who and what. So we want car to honk its horn. And this is the little dividing line right here. This says that the honk horn command is inside of the car class. That's what that dot means. You know, if we wanted to check car1's color, we could say car1 dot color. And what we're doing here is we're accessing the color variable. Man, if there's one thing that you never get better at drawing, it's like those weird curly brace things. Actually, that one came out alright. Anyway, we're accessing the color variable inside of car1. So again, this is the what, and this is the who. So that's what's happening here. You'll notice that it's called self. There's a period. And then there's move right. Now, the set of parentheses, this is the easiest way to tell whether or not it's a function or a variable. If it has the parentheses, it's a function. If it doesn't have the parentheses, it's a variable. If it's supposed to be a function and doesn't have the parentheses, you mistyped it and it's going to yell at you. But that's how you distinguish the two. The parentheses mean that it's a function. And we'll get into why that exists later on. But for now, just note that having a set of parentheses after something means that it is a function. So what we're doing is in the self class, we are calling a function inside of it called moveRight. And that's exactly what happens here. If we run it, what it does is it goes to those moveRight functions, methods, whatever you want to call them, and executes the instructions there. Easy peasy. It knows how to move right, it knows how to move down. It already knows how to do those things because this class has already been written. All we have to do is to tell it to do those things. In this case, self is kind of like a keyword, which always means the thing you're referencing. It's a little hard to explain until you get a little bit more familiar with instances and objects and things like that, but more or less what it means is as you get when you're talking about an object and telling an object to do things, you have to specify what's doing the thing, like in the sense that let me try that again. So let's say you have a car and you want the car to honk the horn, but you've been referring to the car this entire time. Or you have a method or a function inside of the car that that references another method. So let's say we were to look at the honk horn function in the car. Well, we could either do like a print honk or something like that, you know? So we've got this function inside of car that's the honk horn function that just prints the word honk to the screen. I'll over and done with. But what if we had another function inside of car that was called make noise, and it was just a more general function? Well, what we could do is we could tell it to make noise. So let's say we're writing our code. We go car1 dot honk horn. So we've got our program running through the code, and then it gets to here, and it goes, oh, okay, car1 honk horn. All right, I know to go here. And so it goes up here, and it goes to honk horn. And then it goes, oh, make noise. Okay, I know to go here, and then it goes to make noise, and then it runs the code here, like print honk or whatever. Now, this seems silly and superfluous, but there are instances in which something like this would be useful. And again, if you continue along with coding, you'll find plenty of instances in which it's useful. In this case, the self here refers to the fact, that we're going to find the make noise function inside of the car class. That's, really all it means is honk horn here is also inside of the car class. If we want to refer to another function inside of the same class, we can use the self keyword, and that just always means wherever you are right now, there should be something else here that is useful. That's what this is referring to here. So what you can probably glean from that is we're actually writing inside of the player character class. We're giving it commands to move around in order. And we're using self because we're writing inside of the player character class, and these commands also exist in there. Anyway, it took me half an hour to explain level 1, but the next one shouldn't be so long. And again, if we remember from Wednesday, these are supposed to be comments. Comments in JavaScript use the double /. Comments in Python use a £. So it doesn't freak out at you and say that it doesn't understand this, because it's not going to see it. It's going to see the £, and go, okay, ignore everything else in this line. Fine. The reason I'm changing all of these from this to self is same idea. It's because, I see. This doesn't work like an IDE. Is because of the difference between JavaScript and Python. JavaScript uses this, Python uses self. It doesn't make it out, so we've got a little bit more work to do. No, okay. Well, he doesn't have to make it out. Okay. At this point, these are just more exploring what was introduced in level 1 and expanding upon them, sort of using them to solve puzzles. So it's all about anticipating what needs to be done and setting up the proper commands. In this case, we need to tell him to move right once, and then we need him to move around the ogre so the ogre doesn't see him, so we can't tell him to move right again. Tell him to move up, right, down, and then right one more time. So we have him walk around this weird statue of a lion. Manticore. I guess it's a manticore. Anyway, or maybe a chimera. So many different kinds of mythical beasts. Anyway, we have him walk around that statue so that he's not visible by the ogre. And the whole idea is being able to think through how something might play out and anticipating that and setting up the flow of the code so that it does what you want it to do. So you have to think, like, how many times, like, what order do I have to do all these movements into? And while it just seems like puzzle solving right now, that is actually pretty relevant to sort of the mindset you need to be in while you're programming. Is you have to think about how all the moving parts in a program are going to interact with one another and what order you want things to go in. You might have a bug where, you know, you're making a game and a character doesn't render on the screen properly, or you tell it to do something and the whole game freezes up, and you realize it's because you have the order of, like, the background versus the player character rendering messed up, or you have an instance in which it's trying to count how many milliseconds there are from one screen refresh to the next, and in order to keep a consistent frame rate, you can, you know, have it wait for a certain period of time. But sometimes, you know, it takes a smaller amount of time than necessary, and so it calculates a negative thing, and everything kind of flips out. These are just examples that maybe I've run into. But anyway, it's all about controlling the flow of your code, anticipating what's going to happen next, and trying to account for it. And that also helps you write better code too, is as you get better at anticipating how these things are going to work and you learn little shortcuts and things like that, you will start to write more elegant, better looking code, and you'll really feel clever while you're doing it too, and that's the best part. Is you'll write something, you'll go, man, that used to take me 5 steps and I did it in 3, and it works faster and it works perfectly. And you'll just go, I'm the smartest person alive. And then you'll run into something that, you know, you messed up on, but it's okay. You'll fix that too. Make sure, yep, that's what I thought. Some of these are still on JavaScript, some of them are on Python. It's all kind of a mess. Sometimes, as you can see, you've got bonuses here, no code problems, bonus under 9 statements. So what they're trying to do here is they're trying to force you to think more efficiently. Again, by writing as little code as possible and using as much repeatable code as possible in order to achieve that, which is, in essence, modularizing your code. It's more or less doing this here, though this isn't exactly the best example. But it's basically making your code more efficient. Same deal. Turn that into a thing. Self. I don't know if there is a means to change everything at once. And again, this is a pretty extreme example of trying to anticipate how it's going to respond so that you do everything you want it to do. Because A, it looks like, you know, you've got a more little complex kind of area to navigate through, and B, they want you to keep it within a certain number of statements. In this case, 9 or less. Well, less than 9, really, since it says under 9. After completing this level, though, you should get the simple sword, which allows you to make attacks, which introduces another function in Python. And it'll spend some time explaining that too. Let's go ahead and change that to Python. You also get gems for completing the levels, which you can use to purchase better equipment. And then there's this little tooltip down here. Have a problem you can't solve? Google it. It's true, though. I can't tell you how many programming issues, like, I can't think of the particular syntax that needs to happen. Google is a lifesaver. And there's no shame in that. It's nothing wrong with that at all. It's just how it's just the nature of the beast. You know, you either spend time guessing or you can look it up and ask somebody who already knows the answer to that. Self.move rights. And that should self.move right one more time. And this one's simpler, but it's also showing off some of the inner workings behind A, how these characters act, and B, how you'll learn to attack things later on. Oh, I see. Okay, so we had to continue. I did not realize that. And this might seem like a lot of typing for now. Don't worry. As you get further along, you'll start getting the capability to do things like create loops and stuff like that, which will make your life so much easier. Done and done. And we got another simple sword out of it. So having two swords is cool too. Can't pause it. Alright, well. Anyway, this brings up another one. So you'll notice we've got the self.move right, nothing new there. And then we've gotten a command called attack now. The function called attack, self.attack. And you'll notice that the parentheses are still there, except this time we've got something inside of them. In this case, the names of these ogres, Brack and Treg. So we filled it up with Brack and Treg. Now this gets into why functions have parentheses, which is another pretty important thing. So, in the quest to make your code more and more efficient, let's say you created a calculator class, and the calculator can add and subtract and multiply and divide and blah blah blah. It can do all of these things. Now let's say if you wanted to, call on a command, you do like calculator dot add. And of course you got your parentheses there. And you go about it this one of two ways. Let's say you had your add function, right? Oop. And your add function, you asked for like an x. Give me one number and a y. Now, second number. And then, so, x equals and y equals, and, they put in an x and a y, and then you just did x plus y, and then you printed out z. Or answer, whatever you preferred to put there. So z equals x plus y, print z. And that's what you did. But what if you put these up here before the call to add? Well, one of two things would happen. Let's go ahead and move this up here. First things first, let's move this down here, and then we'll move this above it. Oop. Boom. And then we will erase this up here. So first of all, apologies. First of all, we've radically simplified our add. We've gotten our x and our y here. We figure out what they are here, and then all we do here is we just add them together and we print the result. Simple, right? However, computers don't necessarily work that way. In this case, the computer isn't going to know what x and y are here in add, because of something that's fidgety and annoying, but also useful, called variable scope. A variable scope basically means that when you enter into a new function, the computer more or less forgets. It doesn't forget, but it can't see the variables that have existed before. As soon as you leave the function and move on, x and y here will be visible again, and the computer can do with it whatever it pleases, and keep going on its merry way. But as long as we are inside of add, x and y are invisible. So how do we get around that? Well, we can do this right here. What we can do is we can tell the computer that it's going to be expecting some values. It's going to be expecting two values to be placed into the function. And then what we can do is we can feed those values into it. So what's actually happening here is two new variables are being created temporarily while add exists. So x and the y, like let's call these over here A and B. So we'll feed A and B into it. So now what we're doing is we're having the user give you a number, and we're placing it into A, and then we're having the user give you a second number, and we're placing it into B. So we have two variables here called A and B. A and B, like I said, are invisible over here. Then we're calling the add function, and we're taking those A and B that we know, and we're sending them off to add. I know, arrows everywhere. I apologize. Because of the way it's set up, A is going to become X while it's inside of add, and B is going to become Y while it's inside of add. Basically, we created two new variables, X and Y, and then we took the contents of A and dumped them into X, copied them into X. And we took the contents of B and we copied them into Y. So then, X and Y actually have values here. We can add X and Y together to get Z because they have the values of A and B respectively. Then we print out Z, and we come back. X and Y are destroyed. Like, just computer forgets about them, loses them. We come back here, and it remembers what A and B are. And we can continue with A and B if we'd like. In fact, we could do like a multiply, and we could feed A and B into it. And if we had a multiply X and Y, we could again take A and B, deposit them into X and Y, and then do the same thing. Z is equal to X times Y. So that's what's going on here. Is this attack function needs to take in a string. And then what it does is it deals damage to a monster with a name that matches that string. In this case, Brack for the first two and Treg for the second two. So if we were to run it, Brack's up here, he immediately goes to find Brack, kills him, and then goes to find Treg, kills her. Boom. But that's why those parentheses exist, is in programming speak they're called parameters. You can feed parameters in order to make your functions, oops, it's way down here. There we go. In order to make your functions more generic and applicable in a wider range of scenarios. True names, we just did that. The raised sword. And again, it's going to yell at me because it's got JavaScript syntax. And my hero is just going to get destroyed by ogres until we change all of these to selfs. And we'll run it. Notice the semicolons here. Those aren't necessary in Python. They are in JavaScript, but they are not necessary in Python. We can actually, this code will work just fine without any semicolons at the end here. I believe this actually, yep. Haunted Kith Maze introduces loops. And also, it's giving me a hard time to open. There we go. JavaScript, Python, there we go. And this is a prime example other differences between JavaScript and Python. You'll notice here that we've got the word loop, and then we've got these curly brackets. In JavaScript, that's necessary. That's how you can tell everything's inside of the loop. In Python, it actually cannot utilize those curly brackets. It's not going to know. So what we do instead is we pay attention to the white space. In JavaScript, because we have those curly brackets there, we could actually put this loop all in one line and it will work okay. In Python, we not only have to have these each on their own line, but they also have to be indented a certain amount from loop. In this case, I believe Python's case, 4 spaces or the tab key both work. But regardless, they need to be indented in order to show that they're a part of the loop. Oh, whoops, that's right. I need to change these to self. But basically what loops are is they're just bits of code that repeat themselves over and over again. Some loops will repeat them, well, most loops that you write will repeat themselves a certain number of times. Maybe you have a thing that counts to 6 and it's a loop that repeats itself 6 times and prints out a different number each time to the screen. Maybe you have a loop that, let's see here. Well, this would be an example of an infinite loop. You could have a loop where a dude's just patrolling and walking back and forth. And all you'd need is, 3 lines. You'd have loop, and then move right, and move left. And for as long as that loop is running, he'd move right, and then he'd move back left, over and over again, because it's an infinite loop. Or a forever loop. The reason why I'm distinguishing is infinite loop tends to have a negative connotation. Most of the time, like I said, you want to write a finite loop, a loop that ends after a certain period of time. It does its thing, it finishes, and then it moves on. Sometimes, after you've been coding for 6 hours straight, you can insert a little bit of a logic error. And that little logic error turns into a big bug in your code, and that is your code will then run inside the loop forever and ever and ever and never end. And depending on how your code is written, sometimes it can completely lock up the program. That is an infinite loop, because it never ends. In my own personal vocabulary, usually when I'm explaining this kind of stuff, a forever loop is an infinite loop that you did on purpose, and that doesn't break your code. So that sort of gets around the fact that an infinite loop can have negative connotations. Although infinite loop is generally the only way you refer to these types of loops. So as we can see, this is a forever loop. Tells them to move right one more time, move up, and move up again. So if we were to run this, moves right, and then he moves right, and then he moves up, and then he moves up. We hit the bottom of the loop, and we start over again at the top. Move right, move right, move up, move up. And as you can see, it creates this sort of stair-step kind of path. Now, in this sense, we could write, we could have a course that just does this forever. It has this kind of path forever, and he would follow it forever because our loop runs forever and because it's set up to move that specific pattern. And we did it with, well, if we got rid of this comment, 5 lines. Something that would be able to handle that kind of a pathway forever and ever. You'll notice some of these levels have like blue stars. Those just mean that you've got to be a subscriber in order to play them, which is $10 a month. If you get really into it, maybe that's worth it to you. So there you go. But obviously you don't have to subscribe to CodeCombat in order to learn coding. It's just something that you could do. Here's another example of a loop. We'll do this in Python yet again, and it will yell at us yet again because it's written in JavaScript yet again. And then after this one, I'm going to go ahead and do the poll questions. Yes, yes, please double check your code carefully. All right. Same deal. Make sure it's indented so that we know it's part of the loop, and hit run, and it should run through all of the different commands A-OK. All right. So it's 3 minutes till. I know we got started a little bit late, but I want to make sure I don't hold you guys after 9 o'clock. So, like I said, I'm going to throw out the poll questions. Once you've answered those, same deal. If you have questions, feel free to ask them. If you don't, you're free to go, and we'll see you on Wednesday.